Hello students, good morning. Today's lecture we are going to see about the seventh step involved in casing cementing basics, and here you can learn about the casing cementing calculations. So what are the 7 steps involved in this cementing calculation? In our previous lecture we have seen about the cementing calculations in detail, but now this is 7 step involved. What are the 7 steps involved in casing cementing calculations in oil and gas engineering? So let's go to the presentation. So you can see here the a short course on casing cementing calculation. So you can see here in the slide a short course in casing cementing calculation. So here, what are the step-by-step performance in the casing cementing calculation procedures, and what are the well parameters, calculation for volume of cement slurry, then sacks of cement, volume of required mixing water for casing cementing job. So this is your short course contents. Then calculation of displacement, calculation for pressure required to lift the pipe. Then first area of the casing must be found. Then next step is to calculate the weight pipe of the when is hanging the fluid. That is your downward force of the pipe of the well bore. Then calculate the required pressure to start the lift. And the hydrostatic outside pressure, hydrostatic inside, and differential pressure calculations for hydrostatic pressure at certain depth and calculation for resulting force to finish your oil well cementing job. Then calculating the upward force and calculate the downward force. So these are the our course contents. Next slide. So this is your can see the determine the downward force contributed by the cement, then obtain the total downward force and calculating the resultant force after the casing cementing job. So this is your oil well cementing casing. You can see the formations, casing, and cement slurry and cement sheet. So this is the well depth shown for 4,800 meters in the oil well. So this is the schematic. Then you can see here the depth of the uh, ground surface to up to the bottom of different casing, surface casing, intermediate casing, then intermediate casing 2, then production casing. So these are they can see the drill bit, and also you can show the all the uh, casing lines to do the step by do the cementing job. So it is shown here the 3000 meter depth. It is only a reference. So this is your step by step casing cementing calculations and procedures. So this is the 7 critical oil well cement calculation that we made with every surface casing. First one is cement volume. So the volume of cement needed to fill the required footage of the annulus in addition to the shoe track capacity, sacks of cement, converting the calculated volume of cement into sacks, then mixing water required for the given slurries, then number 4 displacement fluid which is mandatory to stop to the top plug from surface to the bottom of the shoe track, then circulating pressure and pressure needed to lift the casing out of the hole. Then number 6 pressure to land the plug, that is differential pressure to pump the plug to the top of the shoe track. Then and this is your seventh one is resultant force which has to be calculated the hook at the top of the casing once the plug has landed. Then these are the parameters. So this is your well parameters for casing cementing calculations. You can see pipe size, well fluid, hole size, pipe depth, Number 5, shoe track length, record cement fill up, then excess volume record percentage. So they given information for oil well casing cementing calculation. So they given here, you can see here pipe size 9.5 by 8 inches, that is LB feet, then well fluid 8.7 LB gallons, then hole size 12.25 inches, pipe day 300 feet, then shoe track length is 40 feet, then record cement fill up to surface, excess volume record in percentage, that is 100%. So this is your data required for the basic well cementing calculation. So now we can see the program, casing program shown in different casing lines. So you can see here conductor pipes, cement, surface casing, and production tubing and intermediate casing, liner and reservoir. So this is the schematic design. You can see here. Then calculation number 1. Let us go for one by one. Calculation for volume of the cement slurry. So that given data, we are going to calculate the amount of cement required for the surface casing cementing job. We have to know the kind of cement, its density and its yield. So for this, we will utilize class C cement, blend as weight 14 point, then yield is 1.32 and water requirement of 6.3 gallon per sack. Now we have to assume that circulated through the surface casing up to depth of 300 feet and a well conditioned hole. So now we have to calculate the volume of slurry required for the job. So first one is number to solve the how much slurry is needed in the annulus multiplied by the annulus length. So first you have to calculate the volume and height between the drill pipe, tubing, casing and whole section within which we are given in the red handbook. So from the table we are selecting for the 9 by 5 inches casing and the annulus we find it 0.3132. Therefore, it is already known that the length is given 300 feet annulus. You have to multiply the volume required to fill the annular space. So there is a volume of slurry in the annulus equal to annual length into capacity. That is feet into feet cube into by feet. So you will get 300 feet into 0.3132 feet, 3 feet. So you will get 93.96 feet cube foot. So this is the volume of slurry in the annulus. We have calculated. Now second is now the volume of slurry in the shoe joint. It's to be calculated in the final step, and the capacity factor of the joint is multiplied by its length. So now we'll see here the length of the shoe track was 40 feet. So therefore the volume of slurry shoe joint equal to capacity factor of the shoe joint and its length. So you are getting 0.4340 capacity factor into 40 feet, you will get 17.36 feet cube. So this is your volume of the slurry in the shoe joint. Now calculate the total volume of the cement. Next C. So that is equal to total volume of cement. You can see here total volume cement equal to slurry volume in annulus plus slurry volume in the shoe joint. So you will get 93.96 plus 17.36 you get 111.32 feet cube. So that is over. Now next is sacks of cement. So we know that the cubic feet required. We can utilize the total sacks required. That is number of sacks required equal to total volume of the cement plus divided by cement yield. So you will get 111.32 feet cube divided by 1.32. You will get 84.33 sack. Then number 3, volume of required mixing of water for casing cementing job. So once we calculate the number of sacks required, we have to calculate the volume of dry water required. So this water should be always a fresh water. So you will get from your handbook data for cementing. So you will get 6.3 gallons of water per sack of cement multiplied by the total number of gallons of mixing water required. Therefore, total required water volume equal to number of sacks into required water per sacks gallon. So first you have to calculate how much mixing water you need in gallons. So now you can see here 6.3 gallons into 84.33, you will get 531.28 gallons. So therefore 43 gallon barrel converted into barrels, so you will get 531.28 into 42 gallons by BL, you will get total 12.65 barrels. So that is your quantity of water to mix the cement. So you will need more water on the rig considering the water is utilized for flushing, spacer, etc. Now number 4, calculation for displacement. Next is the first step in the cementing process is to run the bottom plug. You have to clean the casing from and the mud buildup on the casing wall. Therefore, the cement pumped after the bottom plug will break the plug's diaphragm. Therefore, it will flow through the center of the plug out of the bottom of the shoe. Therefore, then it go up to the annulus. So if the bottom plug is not run, the top plug will wipe down the walls and mud will collect in the shoe joint between the top plug and the cement slurry. Therefore, all the cement which has been mixed, the top plug will be pumped down up to depth of 260 feet. Therefore, it is the number of barrels required, same as the capacity of the casing to the float collar. So you will get displacement volume equal to casing length, which the cement will be pumped through its capacity. So you will get 0.0773 into 260 feet, you will get 20.1 BBL. So next is number 5, calculation for pressure required to lift the pipe. So you can see here, so when the pipe is run into the hole, the movement result in the ram effect. Therefore, this ram effect, what will do? It will increase the running speed. Therefore, the casing of outer diameter of the casing will increase. Therefore, this ram effect may cause the breakage of the weak zones. Therefore, the sand may be slow off and the bridge the annulus. Therefore, in that case of if the casing is stuck, you cannot pull it out without parting. Therefore, these calculations are performed as a precaution. So you can see the pressure possibility of the pipe. So first what you have to do is area of the casing must be found. So area equal to 0.784 into D2. Therefore, we are getting this formula, area of the casing, then plug diameter. That is the area of the circle. So you are getting 9.625, 9.6 inches into 0.784. It's 72.76 inches. That is your plug the diameter. So next you have to calculate the weight of the pipe when it is hanging in the fluid, that is downward force pipe in the wellbore. Therefore, the buoyancy factor of the wellbore fluid you are working on it. Therefore, what you have to do? We have to calculate the weight of this fluid is 8.7 will be per. Therefore, the discipline section from your red handbook, you will get the buoyancy factor of 0.867 for the fluid for the particular weight. So this is the calculation number 2 regarding the buoyancy factor of the wellbore fluid. So now you will get the result. Now you have to know the how much casing weights in the air. Therefore, from the casing stamp, you can find it the casing weight 36 lb feet. Now we have the casing 300 feet. Overall length of your casing is 300 feet for this calculation. Therefore, so weight of the pipe hanging the fluid equal to buoyancy factor into weight per foot of the casing into length of casing. So you will get the downward direction calculation. You can see here. So after this, so you will get 9364.68 lb. That is downward directional force. Weight of the pipe hanging in the fluid. So next, after this, what you have to do? You have to calculate the required pressure to start the lifting. Before that, we have the information to calculate the amount of pressure to apply to the casing at the surface. Therefore, pumping downward through the casing below the casing shoe will start the lifting. Therefore, the larger diameter of the pipe and less pressure is required to lift the string. That is why you have to need the larger casing diameter during the pumping operations. Therefore, we are now doing to start the when applying the pressure to start the circulation, there must be a care should be taken to prevent the pipe blowing out of the hole and causing the damages. Therefore, the pressure required to start the lifting equal to downward force of the pipe divided by the area of the pipe. So this is the required pressure to start the lifting. So you can see here 9364 divided by 772.6, you will get 128.706 psi. Then number 6, calculate the pressure to land the plug during the casing cementing job. So what we have to do here? So you have to need the pressure required to put the cement in place. Therefore, any excess build-up pressure might be indication of channeling or bridging in the annulus. Therefore, the loss of pressure may be or loss of cement in the formations. Because of this, differential pressure will result. So you have to convert the cement and displacement fluid in order to perform the calculation. So for this usage, we are using the constant. That is, if the constant is 0.051595, you have to take constant this and take any fluid weight and convert it into pressure for using the multiplication. So for avoidance of errors in the calculations, you have to form the bottom of the casing up to the surface and calculate the hydrostatic pressures outside and also hydrostatic pressure inside. So now we have to go for the hydrostatic pressure outside and hydrostatic pressure inside of the casing string. So now you can see here the total hydrostatic outside for 300 feet, you got 230.658, and hydrostatic inside cement, so you're getting 30.74 psi. Then well fluid, we're getting total hydrostatic inside for 300 feet, 150.96. So there is a difference pressure equal to, you have to minus both the hydrostatic inside minus outside, you will get 230 minus 150, 76.692. Therefore, for read total depth, you don't end up with the same depth when there is something is wrong. So now, when the plug has been pumped to its landing position and 79.692 psi is the readable on the gauge, so the job has been done successfully. Therefore, in your consideration, you will not have the ability to use the read the pressure to land the plug on all jobs. So now next is calculation for hydrostatic pressure at certain depths. So we are having the pressure of 0.76768 psi feet. So we can use for this one 14.8 gallons into 0.05195 into, that will give the 0.769. That is your pressure. This example hydrostatic pressure. So now for hydrostatic pressure for a particular specific fluid weight, the bone section we can find out from your red book, and that hydrostatic pressure in the casing job pressure is the pressure in the annulus space. Therefore, the plug will shut in the pressure in the casing when it lands in the float collar. Therefore, if you do not land the plug or run the float collar or back pressure valve, but only you have to stop. You have to stop the plug, the casing. So therefore, hydrostatic pressure at certain depth equal to depth into fluid gradient of the fluid in the annulus. So in this case, cement slurry, you will get this 260 feet into 0.78689, you will get 199.914 psi. That is your hydrostatic pressure at certain depth. Now, finally, number 7, you have to calculation for resulting force after finishing the oil well casing cementing. What are the resulting force. So I have to calculate 2 points, calculating of the upward force. So you have calculated already the area of surface casing. In addition to this, you have know the pressure to land the plug, that is 79.692, that is minus the differential pressure. So multiplying these two values give the amount of upward pressure, upward force in pounds. So you will see here, now calculate the downward force. So same one, similarly you will get from the buoyancy factor from the red book, and also the displacement fluid inside the pipe above the float collar 260 feet. The weight of the pipe is 36 lb per gallon. So using the formula, so you will get the downward force. Pounds of downward force equal to length of pipe into buoyancy factor for the displacement fluid inside the pipe into pipe weight per foot. So you will get 8116.6 lb. So now we have to determine the downward force contributed by the cement. So pounds of downward force equal to length of pipe into buoyancy factor for the displacement fluid inside the pipe into pipe weight per foot. So you will get 40 feet into 0.7689 VF into 36 lb. You will get 1107.2 lb. That is your downward force contributed by the cement. So now we will go to the total downward force. We have to add this downward force together. So you will get 8116 plus 1107, you will get the downward force 9233.28 lb. So you have calculated. Now the resulting force after the cementing job should, that is subtract the upward force from the downward force to get the resulting force. So you have 92223 minus 5798.39, you will get 3424.89 lb. So this is your resulting force after the your final result. Calculating the resulting force after the casing cementing job. So now this is the diagram, and you have completed all the 7 steps. I think now you can see the final diagram, formation of oil well cementing, casing cementing job. So casing cement formation interface, then cement. So these are the short course which we have seen today. So now we have completed the short course on casing cementing operation in oil and gas engineering. Thank you. Subscribe my channel. We'll see more cementing calculation videos in our next lecture. Thank you.